the edge of the universe isn't what you think. It's not a wall. It's not a cliff. It's not even a place. And yet, you've always imagined it, haven't you? A faraway border where the stars thin out, where space fades into something else. Nothingness. Maybe. But what if I told you there is no edge? And at the same time, there is. What if I said the very idea of an end to the universe is a trick, an illusion built from the limits of your own perception? You see, the Big Bang didn't explode outward into empty space. There was no outside, no vast darkness waiting to be filled. Space itself was born in that moment. Time, too. Everything you know, every galaxy, every atom, every breath you've ever taken, emerged not in space, but with it. And that means the universe didn't expand into anything. It became the very fabric of where and when. So if there was never an outside, where does it end? Maybe you're starting to feel it now. That slow unraveling of your reality. That creeping chill as the scaffolding of certainty starts to collapse. Because here's the real contradiction. If the universe is infinite, it has no edge. But if it isn't infinite, then what lies beyond the edge? Is it a void? A boundary? A cosmic mirror reflecting us back into ourselves? Or is it something worse, something we're not meant to see? Let's step back. Imagine a balloon not floating through space, but being inflated. Now, imagine you're a tiny speck on its surface. The balloon stretches. The speck moves away from every other speck. But here's the twist. You're not expanding into the air around the balloon. You're part of the surface, the two-dimensional skin of a three-dimensional object. You can walk in any direction, travel endlessly, and yet, you'll never reach an edge. You'll never fall off. That surface has no boundary, even though it's finite. That, perhaps, is our universe. A boundless thing with no outside, growing, larger and larger. Not into something else, but into more of itself. And yet, we've seen something strange. As we peer deeper into the abyss, further into the past, we find a limit. A wall of fire. A veil of light. The cosmic microwave background. Fossil radiation from a time when the universe was just 380,000 years old. We can't see beyond it. Not with eyes, not with telescopes. It's as if the cosmos is telling us, this far and no farther. But that can't be the edge. Can it? Because what lies beyond is not empty space. It's time before light. A darkness too hot to shine. An era so young the very atoms had not yet calmed enough to let photons pass through. And if we could push past that veil, what would we find? A younger universe, compressed and burning? Or the truth, that there is no beyond, that we've already reached the limits of what the cosmos will ever allow us to know, unless the universe is curved in a way we cannot yet grasp. What if light from the beginning is still traveling, only to loop back around and meet us from behind? What if the edge is not out there, but within? What if the end of the universe is staring at us from every direction, wrapped in the illusion of distance? You might be wondering now, how do we measure something with no boundary? How do we map a cosmos that may bend in on itself like a four-dimensional Mobius strip? And more disturbingly, if it is infinite, why does it look so structured? So ordered? So just right for life? Here's where the story grows darker. Because the more we study the edge, the more it disappears. Galaxies flee from us in all directions, not because we're special, but because everything is moving away from everything else. And the farther they go, the faster they flee, red-shifting into oblivion. One day, not so long from now, in cosmic time, the last galaxies will vanish from sight altogether, not because they cease to exist, but because the universe grew too fast to keep them in view. The edge will come to us, not as a wall, but as a silence, a sky that grows darker not from nightfall, but from retreat, from expansion so violent it rips the very possibility of sight from our eyes. So I'll ask you now, what's scarier, a wall at the edge of the universe, or the idea that it has none at all, that we're sailing through a boundless dark sea, where every light is temporary, every answer incomplete, and every boundary we imagine is just a mirror of our own limitations? No, the edge of the universe isn't what you think. It isn't where it ends. It's where you begin to wonder. Imagine the universe in its infancy, not the twinkling stars you see overhead, not the galaxies spiraling in majestic ballet. Go deeper, before all that, before light, before atoms, before time had a name. The early universe wasn't just hot, it was a roaring, incandescent furnace where time itself was still learning to move. A place where space churned like a stormy ocean, each wave a quantum fluctuation surging with possibility. We call it the Hot Big Bang. But that name is deceiving. There was no explosion, no thunderous roar in a silent void. Instead, there was emergence, expansion, a moment where everything, every speck of matter, every law of physics, every dimension you can imagine, erupted from nothing into everything. At least, that's the story we tell. But as we step closer, as we set the stage and pull the curtain back on this grand cosmic performance, the ground begins to shift. What we think we know starts to unravel. The laws we've trusted become riddles, and the light we use to peer into the past, it begins to lie. Let's start with something familiar. Light, you know it as the warm glow of the sun, the quiet flicker of a candle. But light is far more than a beam or a spark. It's a time machine. Each photon is a message from the past, an ancient whisper traveling across the dark canvas of space. Some of the starlight hitting your eyes tonight began its journey before humans walked the earth. Some, even before Earth itself was born. Through light, we see the past. We measure it. We believe we understand it. But light can only travel so fast. And space? Space cheats. It stretches. As the universe expands, it pulls the very fabric of light with it, dragging each photon like a ribbon in the wind. The result? The farther we look, the redder the light. Until, finally, the signal fades into the background, the cosmic microwave background, the oldest light in existence. A ghost of the infant universe frozen in time. This is our limit. Beyond it lies darkness. Not a shadow, but an epoch. A time before transparency. Before light could escape. Before the universe cooled enough to form the first atoms. A blinding fog of energy so thick, photons ricocheted endlessly, never traveling in a straight line. We call this the last scattering surface, and it's the farthest we can see. But even this light, this ancient relic, is not the full story. Because if the universe is truly infinite, then why does this horizon feel so finite? Why does the observable universe, a 93 billion light-year bubble, seem just right for us to exist in? Why are the fluctuations in the cosmic microwave background so uniform, so smooth, yet sprinkled with just enough imperfection to birth galaxies, stars, and life? Cosmologists call this the horizon problem, a contradiction at the heart of everything. You see opposite ends of the sky, billions of light years apart, look nearly identical in temperature and structure. But in the early universe, there wasn't enough time for light, or anything, to travel between them. So how did these distant regions know to match so perfectly? How did the universe synchronize its own birth? To fix this paradox, science offered an elegant solution: cosmic inflation. A brief, unimaginable moment when the universe expanded faster than the speed of light itself. Not just rapidly, exponentially. Space ballooned outward, smoothing irregularities and stretching tiny quantum ripples into the seeds of galaxies. In less than a trillionth of a second, the universe grew from smaller than an atom to something the size of a grapefruit, or perhaps even larger. Inflation explained a lot. It made the observable universe make sense. It gave order to chaos. But here's the problem. It also opened a deeper mystery, because if inflation happened once, why not again? Why not everywhere? Some physicists now believe inflation never truly stopped. That while our observable universe slowed down and cooled, other regions kept expanding. And expanding. And expanding. Spawning new universes like cosmic bubbles in an ever-boiling sea. This is the multiverse hypothesis. A reality not of one universe, but of infinite universes. Some eerily similar to ours. Others governed by laws so alien we can't even describe them. And suddenly, the edge of our universe is not an edge at all. It's a bubble wall, a membrane separating our cosmic domain from countless others. Floating in a higher dimensional space we cannot access. But let's pause, because this raises a question more disturbing than any yet posed. If the universe has no edge, then where does it begin? Not in time, but in space. If we're inside a bubble, what surrounds the bubble? If space is stretching, what lies outside the stretch? This is where the metaphors collapse, because the moment you try to picture an outside, you run into a wall, not a cosmic one, but a cognitive one. Our minds are wired to understand beginnings and ends, insides and outsides. But the universe plays by no such rules. It isn't inside anything. It is the everything. And yet, something haunts us. The discovery of dark energy, a mysterious force driving the universe to expand faster and faster, suggests that not only is space growing, it's accelerating, as if something at the edge is pulling it outward, or pushing it from within. But what is dark energy? A property of space itself? A new field? A whisper from another universe bleeding into ours? No one knows. And as the universe expands, galaxies grow more distant. One day, they'll recede so fast that their light will never reach us again. And then, we'll be alone, floating in a sea of darkness, surrounded by silence, imprisoned by a horizon that shrinks with every passing eon. That's the future. But what about the origin? There are whispers, equations that hint the Big Bang wasn't a beginning but a transition, that before the bang, there was something else, a collapsing universe, a mirror cosmos, a cyclical rhythm beating across eons. The idea is called the Big Bounce, and if it's true, then we may be one note in an eternal cosmic symphony. And still, the question lingers: if the universe began from nothing, what is nothing? not empty space, not a vacuum, but true nothing. No time, no laws, no logic, the absence of everything. How does something arise from that? How do we explain a beginning that has no cause, no reason, no precedent? We don't, we can't, and yet, here we are, standing on a tiny rock orbiting a modest star in a quiet arm of a galaxy, wondering, reaching, building instruments to measure the invisible, launching satellites to map the oldest light, smashing atoms to recreate the birth of reality itself, searching for the edge of a universe that may not even have one. And so, the stage is set. The curtain rises, and the mystery deepens. You've always lived inside time. You wake, you age, you die. It feels linear, unstoppable, a river that only flows one way. But what if time doesn't flow? What if time is frozen, every moment stacked atop another, like frames of a film reel, where nothing moves, unless consciousness presses play? Imagine this. You're holding a reel of film in your hands, frame after frame, frozen images. A kiss, a tear, a death. They exist simultaneously, waiting for the light of a projector to bring them to life. From the viewer's seat, the movie seems to unfold, but behind the illusion, nothing truly changes. That, some physicists believe, is how reality works. It's called the block universe, a model where the past, present, and future all exist at once. Time is not a river, but a landscape. You don't move through it. It's already there, fully formed. You are simply experiencing one slice at a time, and just like a hiker on a mountain trail. Your journey is local, but the mountain exists in full, even before your first step. Let that sink in. Because if time doesn't flow, then neither does causality. Events don't cause one another. They just are. And the arrow of time, that sensation of moving forward, it's not fundamental. It's thermodynamic, a byproduct of increasing entropy, the universe's tendency to move from order to chaos. But what if entropy could reverse? In certain quantum models and near black holes, this arrow begins to wobble. In regions of extreme gravity, time slows. Near the edge of a singularity, it may even stop, or split. And this is where the first theory slashes through your understanding, like a blade. The singularity. The singularity isn't just a place. It's a boundary where the laws of physics break, where math yields infinities, where space folds into itself so tightly it tears. Think of it as the center of a black hole, but also the start of the universe. The Big Bang itself may have been a singularity, an infinite point of energy and density compressed into nothing, then bursting into everything. But here's the twist. Singularities don't make sense. Our physics collapses there. General relativity predicts them, but quantum mechanics rejects them. They are contradictions. Mathematical fossils of a deeper truth we haven't yet uncovered. So scientists dug deeper. That's where the second theory emerged, one that rewrote the beginning of time itself. Loop quantum cosmology. In this view, space is not smooth. It's granular, made of tiny loops stitched together like fabric. At the smallest scale, the Planck length, space and time become pixelated, digital. And in this model, the universe never hits an infinite density. Instead, it bounces. A big bounce. Before our universe expanded, it contracted. A previous cosmos collapsed under its own weight, crunching down to an ultra-small size, then rebounding. Into ours. Just as a ball dropped onto a trampoline squashes and launches upward, the universe might be locked in a never-ending cycle of birth, death, and rebirth. And suddenly, the singularity dissolves. The beginning was not the beginning. It was a turning point. But if our universe came from a previous one, where did that one come from? And the one before it? This leads us to the third, most mind-warping idea yet. The multiverse. You've heard of it in science fiction. Alternate Earths. Mirror selves. Universes branching off with every decision. But real physics, serious, peer-reviewed physics, is starting to take it seriously. There isn't just one multiverse theory. There are many. The quantum multiverse. Every time a quantum event occurs, the universe splits. Schrödinger's cat doesn't just live or die. It lives and dies in two parallel timelines. Every possibility is realized. Every coin flip, every choice, every action spawns another universe. The inflationary multiverse. During cosmic inflation, some regions of space expanded faster than others. Some never stopped. Our universe is just one bubble in a vast cosmic foam, each bubble birthing its own physical laws, constants, and realities. The brane multiverse. In string theory, our universe is a 3D membrane, a brane, floating in a higher dimensional space. Other branes could exist parallel to ours. When they collide, bang! A new universe is born. Each theory takes us further from comfort and closer to madness. Because if the multiverse is real, then you are not singular. There are infinite versions of you, some nearly identical, others wildly different, where you were never born, where your parents never met, where your atoms formed stars instead of skin. And the edge of our universe? It's not a wall. It's a membrane, a border between realities, untouchable, unknowable, and yet achingly close. But here's the problem. We may never see it. The laws of physics inside our bubble prevent us from peering beyond it. Like fish in a bowl, we see only the water we swim in. The glass is invisible, but that doesn't mean it's not there. Now, imagine this. You're standing in a hallway of mirrors. Each reflection looks like you, but slightly off. One smiles, one frowns, one is older, one is dying, one is reaching back. This is what the multiverse implies, that the you watching this story may only be one version in an infinite theater of possibilities. And if infinite versions of the universe exist, does that mean our universe is random? An accident? A fluke? Physicists call this the fine-tuning problem. Our universe appears perfectly calibrated for life. If the strength of gravity were off by a decimal, if the electron were slightly heavier, if dark energy were just a bit stronger, stars wouldn't form, atoms wouldn't bond, life wouldn't emerge. Why is everything so precise? The multiverse offers one answer: selection bias. Of course, we find ourselves in a universe fit for life, because in the infinite multiverse, only the universes that support observers get observed. All the others? Silent, lifeless, forgotten. But this idea is controversial. Some call it science, others philosophy. And yet, as telescopes peer deeper and deeper, we begin to see strange alignments, patterns in the cosmic background radiation that hint at something else. A bruise, a cold spot, a ripple in the sky. Could it be a collision? Could our universe have brushed against another? Some theorists believe yes, that during inflation, our bubble may have bumped into another, leaving a scar in the ancient light. A cosmic fingerprint. But how do you prove a world beyond the world? How do you touch the untouchable? We reach for answers with equations. We build colliders. We send satellites into space. But perhaps the edge of the universe isn't out there. Perhaps it's within, because the next theory doesn't come from space. It comes from the smallest things imaginable. The holographic principle. It sounds like science fiction, but it may be science fact. According to this idea, everything you see, every galaxy, every atom, every thought, might be a projection. A 3D illusion cast from a 2D surface on the edge of the universe. Let that settle. The world feels solid, deep, real. But mathematically, it may be no different than a hologram on your credit card. Just information encoded on a distant boundary, playing out like a simulation. This theory emerged from studying black holes. When matter falls into a black hole, it disappears from view. But Stephen Hawking proposed it doesn't vanish. It radiates, slowly. And over eons, the black hole evaporates. But this raised a terrifying paradox. What happens to the information? In physics, information cannot be destroyed. It must go somewhere. But if a black hole swallows it and then evaporates, where does it go? The answer shook science to its core. Some physicists now believe the information doesn't disappear. Instead, it's stored on the event horizon, the surface of the black hole. Not in the hole, but on it. And if that's true, maybe our entire universe is the same. A projection from a distant edge we cannot see. What if everything you know is a lie wrapped in comfort? What if every heartbeat, every decision, every love and loss wasn't yours to begin with? What if it had already happened, infinite times before, played out, frame by frame, in a cosmic loop beyond your control? That's not just speculation. That's what time says. If time is not a river, but a landscape, then free will becomes theater. You are not choosing your path. You are walking one already carved in stone. A memory that mistakes itself for choice. And if that's true, then what are you? A traveler? A ghost? Or just an echo bouncing through the chambers of a deterministic universe? Breathe for a moment. Let it hit you. Because this isn't just philosophy anymore. The deeper we've looked into the heart of the cosmos, the more the universe stares back. And it doesn't blink. It doesn't care. It doesn't notice. This place is cold and vast and old in a way that sears the soul. Imagine standing in a frozen void, beyond all stars, beyond all galaxies. There's no light, no sound, only you, and the truth, that everything you ever loved was a statistical blip in a meaningless sea of quantum foam. The universe doesn't just not care about you. It doesn't even know you exist. Your entire planet, your history, your pain, your triumphs, they're a shimmer on a soap bubble, a brief flash of warmth in an ocean of dark, a flicker, then silence. That's not poetry. That's the math. We are infinitesimal, a grain of sand within a storm of galaxies. We orbit a star that will one day swell, then die. Our galaxy spins through a web of dark matter that may never reveal its purpose. And beyond it all, space continues to stretch, faster and faster, pulling everything apart until nothing is left but cold. This is the future physicists call the heat death, A time when all stars have burned out, when black holes have evaporated, when the last proton decays. A universe at perfect equilibrium, dead, frozen, and eternal. Time, in this bleak future, becomes meaningless. There is no change, no memory, no life. Can you imagine it? A night so long it consumes everything? This is what awaits us. Not by choice, not by punishment, just by design. And yet, you're still here, listening, breathing, feeling something stir. Because inside you is a question louder than fear. Why? Why a universe at all? Why a moment of brilliance in an ocean of silence? Why the unbearable beauty of life, if it's all destined to end? Maybe the truth is worse than you thought. Maybe the universe is alive. Maybe we are not its observers, but its thoughts. Fleeting neural sparks in a mind so vast, we mistake it for nothingness. And when the thought ends, so do we. Or maybe we're alone. The only eyes that can look up and wonder. The only mouths that can ask, why? In a cosmos that will never answer. That is its own kind of horror. Not cosmic malevolence, but cosmic indifference. And still, we build meaning. We draw constellations in the stars. We write symphonies. We fall in love. Why? Because something in us refuses the void. Something ancient, defiant, and full of light. A whisper passed down through atoms and stardust, echoing in our DNA. You matter. Not because the universe says so, but because you say so. And maybe that's enough. But what if, just what if, the universe does notice? What if the laws we think are cold and mechanical are actually whispers? What if the symmetry of physics is not randomness, but rhythm? And what if the universe has been singing to us all along? If so, we've barely learned to hear it. This cosmos, with all its terror and silence and mystery, might still be a cradle. One day, perhaps, we'll outgrow this tiny Earth. Step beyond the cradle. Reach into the stars. Not to escape death, but to understand life. We may never find the edge. We may never learn the truth. But maybe, just maybe, the search itself is sacred. So here we are, at the edge of understanding. Or perhaps, at the illusion of one. You've walked the timeline of creation, stepped across singularities and bled through quantum paradoxes. You've held time in your hands, watched galaxies breathe, and felt the silence where light once lived. But there is one more possibility, a final theory, one that's more unsettling than all the rest. What if the universe is already dead? Not metaphorically, literally, cold, still, gone, and everything you're experiencing right now, this moment, this breath, this heartbeat, is just the echo of something that already ended. This is the theory of cosmic holography, taken to its most extreme conclusion. Some physicists believe that our reality, the stars, the planets, your memories, might not be unfolding in real time. Instead, what you're living could be a recording, a playback. The final flickers of a dying system reliving its past, encoded in the outermost shell of space. A universe that has already collapsed. Still dreaming of what it used to be. You're not in the universe. You're remembering it. Like neurons firing in a frozen brain, flashing with memory even after the body has ceased to move. Now imagine that on a cosmic scale. Everything that ever existed, compressed onto the edge of space, like data etched on the surface of a black hole. Our entire universe, a final pulse of memory running its course, a dying dream in the mind of time. If that's true, what does it mean for you? Maybe your thoughts aren't shaping the universe. Maybe the universe is shaping you. Not in real time, but as part of a story already written. And the edge you've been chasing, the boundary of it all, was never meant to be found. Because it's not out there. It's the moment the dream ends. The memory fades. The last photon vanishes into absolute zero. But don't despair, because there's beauty in this ending too. Look up. Somewhere, beyond the visible sky, a galaxy is being born. Spirals of newborn stars stretch their arms across dark matter scaffolds, glowing with the fire of nuclear fusion. Entire solar systems swirl into place, worlds that will never see us, never know we existed. And yet, they are part of our universe. Universe that once sang in gravitational waves, pulsed with supernovae, danced in electromagnetic storms across the cosmic web. Even if it's ending, it was magnificent. And what if this isn't the end? What if this whole thing, our universe, our story, is just a single note in a larger symphony? A breath in something far older? Far bigger? There's a theory, one final whisper from the edge of cosmology, that we are inside a simulation. Yes, it sounds absurd, but it's gaining traction among serious physicists and philosophers alike. Because as we break down the universe, as we dig into the deepest levels of reality, we find code, patterns, mathematical symmetries so precise, so exact, that they seem less like accidents and more like architecture. DNA is digital. Space-time behaves like a grid. Particles snap in and out of existence like subroutines. Quantum tunneling, entanglement, non-locality. It all behaves like computation. So what if the universe is code? What if every galaxy, every heartbeat, every burst of gamma rays is the rendering of a system far beyond our comprehension? What if the Big Bang wasn't a birth, but a boot sequence? We wouldn't know. We couldn't know. We are inside it. And just like a character in a video game cannot see the screen, we cannot touch the fingers that wrote the code. But maybe, just maybe, we can feel their shadow. In déjà vu, in synchronicity, in the uncanny perfection of universal constants, or in the feeling you get when you look up at the night sky and feel something looking back. Maybe we are real. Maybe we are the echo of something greater. Or maybe we're just the dream of something that's already gone. And so, we return to the question we started with. Where is the edge of the universe? The answer is simple and terrifying. It's everywhere. And nowhere. It's the limit of what we can see, the boundary of what we can know. It's the question that unravels the very idea of questions. It's not a place you reach. It's the moment you realize there's nothing left to find. And yet, somewhere in this infinite expanse, in the silence between the stars, in the data encoded on the cosmic horizon, another version of you might be watching this right now, asking the same questions, hearing the same echo. Because if the universe is truly infinite, then everything that can happen does, somewhere, always. And in one of those universes, you already know the answer. But here, in this one, the edge remains, just out of reach, just out of sight, forever waiting, forever watching, forever unfolding. The universe's edge isn't what you think. It's what you were never meant to see. You've traveled across time tonight, not in a ship, not in a dream, but in thought. And thought can go further than light ever will. We began with a contradiction, a riddle, a whisper in the dark. Where does the universe end? We shattered the comfort of answers, pulled apart the illusions we once called truth. We stood at the feet of giants, Hawking, Penrose, Einstein, Tegmark, and climbed into realms where even they dared only to speculate. You saw the singularity. You walked the loops of time. You brushed against the multiverse. You stared down the heat death. And you emerged not with certainty, but with awe. Because awe is what remains when answers disappear. We told you the universe had no edge. And yet, we found many. The edge of time, the edge of light, the edge of thought itself. And beyond those, something more terrifying. The possibility that everything has already happened. But the story doesn't end here. Because the universe is still expanding, still evolving, still writing itself. And you are part of it. Right now, as you sit in your room, or walk your quiet street, or lie staring into the blackness behind your eyelids, you are a node in the universe's mind, a fleeting but brilliant flare of self-awareness. You're not just in the cosmos. You are the cosmos, curious, thinking, wondering what it all means. And in that wonder, you're doing something the stars cannot. You're giving the universe meaning. So the question remains, will you forget? Will you go back to routine, to bills and texts and traffic lights, pretending this moment didn't shatter you, just a little? Or will you carry the question forward because the universe doesn't give you answers? It gives you questions and the courage to ask them, again and again and again. And so we leave you here, not at an end, but at a threshold, a door without a frame, a path without a map, a mystery that stares back when you stare too long. But before you step away, let me leave you with one final thought. What if the universe is asking you the same question? What if all of this space, time, energy, chaos wasn't just something for you to explore, but something that's been watching you, waiting to be understood? And what if understanding it changes it? You were never just an observer. You were never just a traveler. You are a mirror, and in you, the universe sees itself.